Okay, students. So let us start. We are studying electromagnetic. Let me just quickly share the PDF. Okay, fine. So we are studying electromagnetic waves and communication system. Yes or no? And till now we have covered a lot of part for electromagnetic waves. Okay, fine. Now as I said, what we'll be doing is we'll be first doing the numericals. All right. So now, just 1 second. What we can do is everyone quickly go to your page where all the questions are, after the chapter where page number 241. Okay, everyone please go to page 241 of your textbook. Okay, so students, see, in all we have 9 numericals here, but we will be solving today only till the 6th numerical. Okay, the 7th, 8th and 9th one, it is actually based on the concept that we'll be studying later. So that those numericals we won't do now. Till 6th numerical we will be solving. Okay, fine. So now what I'll do is, okay, first let me just quickly or what I can do is I can ask someone to read the question for me. I'll write it down in the whiteboard. Okay, so can anyone please read out the first question for me? Just look into your textbook and read out the question.
Calculate the frequency of in megahertz of a radio wave of wavelength 250 meter.
Okay, so they have asked us to calculate the frequency in megahertz of a radio wave of how much?
Wavelength 250 meter.
250 meter. Okay, students. So what they have done is they have given us wavelength, which is represented by lambda. Again, students, I'm repeating, you all can denote frequency by F, or you all can write mu instead of that. Okay, fine. It means the same. Just 1 second. All right. So you all, I suggest stick to mu because that is the notation that is used in your textbook. Okay, fine. But actually, I have a habit of writing small f for frequency. That is why. If you all write small f also, that is not incorrect. It is correct only. But again, textbook notation is mu, so stick to mu. Okay. Yes. Ritesh, please continue the question.
Remember that the speed of all EM waves in vacuum is 3.0 into 10 raised to 8 meter per second.
Okay, so this is something we already know, students. Yes or no? This is one of the characteristics of EM waves. That is, the speed of EM waves in vacuum is equivalent to the speed of light. That is 3 into 10 raised to 8. So even if I don't mention this in the question, you all should know this already. Okay. Yes, Ritesh, please continue.
Is done.
Okay, done. Could you just, okay, fine. Thank you so much, Ritesh. All right, so what is given in the question? Students, see, always, whenever you all are solving numericals, no matter whether it is for 2 marks, 3 marks, 4 marks, it really doesn't matter. Always follow this pattern, okay? First write the data, then write the to find, okay? And then write the solution. So this is like, a very systematic representation of writing numerical. So according to this sum, first I'll write data, and below data I'll write whatever wavelength and this thing is given. Okay. Then to find is my frequency. Frequency should be in megahertz. So basically what they're trying to tell is the final answers that you all will get should be in megahertz. Okay. It should be represented in megahertz. Can anyone quickly tell me how much mega stands for? Mega is how much value? Capital M. You all remember in the last lecture, we have seen a green box in your textbook, which indicates all these values.
6 hertz.
Yes, very good, Ritesh. It is? Yes, very good, students. Mega stands for, mega is equivalent to 10 raised to 6. Okay, fine. And then in the solution part, okay. Now, very simple numerical, students, very simple. See what is available. See what you all are supposed to find. And can anyone tell me what formula I can apply over here, or how I can obtain the solution?
C is equal to frequency into
mu.
C is equal to
lambda into frequency.
C is equal to lambda into frequency. Okay, correct. Very good. See, students, I have told you all already multiple times. Remember this formula. Okay, what formula? That lambda is C by F. Again, I'm repeating in your textbook, wherever frequency is present, they have denoted it as mu. So you all stick to mu only. Lambda is nothing but C by mu, where lambda is wavelength, C is the speed of light or speed of EM wave in vacuum, and mu is the frequency. So this formula you all have to remember. Now students, in this formula, I know the wavelength and I know value of C. I have to find mu, right? So what I'll do, I'll simply rearrange this formula, yes or no? So just 1 second. Where's the eraser? Okay, I'll simply rearrange this formula. So after rearranging, what I get is, okay, I'll get mu as, okay, lambda is C by F. So mu, that is frequency, I'll get it as, just interchange the positions, I'll get this. Yes or no? Okay, formula is lambda is equal to C by F or C by mu. So I need mu. So whatever you all need, bring it on one side and all the known terms on other side. Okay. So now simply substitute the values. Okay. And now this part you all have to do. You all can write these sums along with me. Okay. As I'm explaining along with me, start noting it down in your notebook in this pattern. Okay. In this data to find solution pattern. All right. So first write the data, that is lambda and C, then write to find, that is the frequency, then under solution, first write the original formula, students. What is the original formula? Lambda is equal to C by mu. And then in the next step, rearrange the formula. Take mu on one side, which is nothing but C by lambda. Write down the values. Students, you are always supposed to show the values, okay? Do not simply write the final answer. Show the values. And then solve this and tell me what is the answer that you all are getting. Please don't directly tell the answer from the textbook that is written. I don't want that answer. Okay. Like, I don't want that direct answer. I want you all to solve it first. Okay. So, done. Okay. Lenroy is done with the sum. Okay, good, Lenroy. I'll wait for a minute for others to solve. See, students, here, I mean, you all can do log calculation, okay? There's no harm in doing log calculation over here, but this is a very simple calculation. Like, there's no need. See, whenever you all do log, then you all have to, without fail, take anti-log as well, which many students forget, okay? So this is like a basic division that you all can do. So what you all can do is, it is 250, right? So basically it is 25 into 10. So I can cancel out 110 with the numerators 10 raised to 8. Simply divide 3 by 25. Okay. I think so that much basic division you all can do. Done. Okay. Shraddha is done with this. Okay. I hope everyone is solving. I'm waiting for others to solve as well. Okay. Okay, many of you all. Students, if you all would just unmute and tell, it would be really helpful. Okay, fine. Okay. So now, okay, so now for this one, what I'll do is, I'll tell you all how to do this. Students, I'm just clearing out, or I can go down a little bit, just a Okay, I'll try to write it over here. Okay, so as I said, what you all do is cancel out the 10. Okay, so you all are left with 3 by 25. Okay, into that 10 raised to 7 is going to be as it is. I hope you all understood what I did over here. Now what you all do is divide this 3 by 25. So 3 by 25 is nothing but, anyone? 10 raised to 7, right? This is what I got. 3 by 25 is nothing but, student, 0.12 into 10 raised to 7. Now this answer that I have obtained, okay, this answer that I have obtained, it is in hertz, students. Always remember, your formulas that are there, your formulas are always based on SI units. Okay, fine. So hertz is an SI unit, and then wavelength meter is an SI unit. Okay, fine. Meters per second is an SI unit. So basically this answer that I've obtained is in hertz. But in the question, they have mentioned that my final answer should be in what? In megahertz. And we all know when I can substitute mega, I can substitute mega when I have something called 10 raised to 6 with me. So how can I do the transition from 10 raised to 7 to 10 raised to 6? Anyone? What am I supposed to do over here?
Divide 1 point
Decimal.
Yes.
decimal place.
Shift the decimal
Shift the decimal where?
on right.
On
To
right
the
side.
right hand side. Yes, yes, very good students. Okay, so when I shift the decimal to the right hand side by one place, I will have into 10 raised to minus 1, right? When we go to the right hand side, it becomes minus. When we shift it voluntarily to the left, it is plus. Okay, it is opposite of what the actual number line is. So when I shift it to the right hand side, I'll have 10 raised to minus 1. So 7 and minus 1 will give me 6. And here, instead of this 10 raised to 6, I can simply write megahertz. So this is my final answer. Okay, very simple numerical students, very simple formula, very simple calculations, no need to do anything complicated. Okay, let's see the second sum. Can anyone just read the second sum for me? Some other student read now.
Calculate the wavelength in nanometer of an X-ray wave of frequency 2 into 10 raised to
Okay,
18
wait,
hertz.
wait dear, let me just write down the data. Just go a little slow. Okay, calculate the wavelength in nanometer. Okay, then continue.
Of an X-ray wave
Okay, the wave type over here they have mentioned. Again, students, don't worry about this. As I said, the electromagnetic spectrum that we are going to study, the entire spectrum is divided into various bands. So every band has its own name. One band is known as X-ray band, one is ultraviolet band, one is visible band. Okay, so actually here, this X-ray part doesn't matter that much. You all will see why. Okay, please continue.
of frequency 2.0 into 10 raised to 18 hertz.
Okay, 2.0 into 10 raised to 18 hertz. Okay. Then,
Done, miss.
okay. Now, okay, fine. So the question is, students, we are supposed to find wavelength and all they have given us is just frequency. So can you all tell me how will the solution come over here? What I can use over here?
Lambda is equals to C upon nu.
Yes, lambda is equal to C upon mu. Very good, students. Same formula. As I said, C's value, okay. Okay, Lenroy has already done the sum. Good, good, good. Very good, Lenroy. See, as I said, C's value is going to be fixed, right? 3 into 10 raised to 8. C is nothing but speed of light. C is speed of EM waves in vacuum. Yes or no? It is not going to change. So even if it has not, if they have not mentioned it in the question, we should know that it is present over there. Okay. So here, C is what? 3 into 10 raised to 8? Yes or no? And what is mu? Mu is 2 into 10 raised to 18. So can anyone tell me what is the lambda that I'm going to get after solving this? Not the final answer. First tell me what will happen after doing the basic calculations. Like first do 3 by 2. Then I have 10 raised to 8, right? Then take this 10 raised to 18 in the numerator. So it will become 10 raised to minus 18. So can anyone tell me? Okay, all are sending in chat. Okay, yes, Shraddha, correct. Others, can anyone, can someone answer, please? Unmute and answer. Yes, Lenroy, correct. Yes, yes. Okay, you all are sending correct answers, students, on chat. Can, if anyone would just unmute and tell.
1.5 into 10 raised to minus 10.
Yes, very good, very good. Okay, 1.5 into 10 raised to minus 10. So where did this 1.5 come from? 3 by 2. और ये 10 raised to minus 10 कहाँ से आया? 10 raised to 8 into, if I take this in the numerator, it will become 10 raised to minus 18, right? So 8 minus 18 is minus 10. Now the answer should be in nanometer, students. What is nano's value? Nano stands for 10 raised to minus 9, right? So अभी ये जो 10 raised to minus 10 है, इसको मुझे minus 9 पे convert करना है. So how will I do that? Where will I shift my decimal point? Towards right or okay? Firstly, see.
Left.
1 second students. Okay, see, if -10 को -9 बनाना है, तो I have to add 1, right? If I'll do +1, then it will become -9. Yes or no? So where will I shift my decimal point? Left hand side or right hand side?
Right side.
Left side.
Listen carefully.
Left side.
Left hand side. Okay, yes, correct, very good. See students, कैसे याद रखना है? देखो, I'll tell you all. तुम्हारा जो नंबर लाइन होता है, नंबर लाइन पता है ना सबको, या फिर तुम्हारा जो 4 एक्सेस होता है, क्वाड्रेंट वगैरह, तो राइट हैंड साइड में क्या होता है? पॉजिटिव वैल्यूज, लेफ्ट हैंड साइड में क्या होता है? नेगेटिव वैल्यूज. ओके, सो व्हेन यू आर शिफ्टिंग डेसिमल पॉइंट, ओके, व्हेन यू आर मतलब तुम लोग खुद से शिफ्ट कर रहे हो. ओके, खुद से जब तुम लोग राइट के तरफ शिफ्ट कर रहे हो, मतलब पॉजिटिव एक्सिस के तरफ शिफ्ट कर रहे हो, तो माइनस आता है, उल्टा आता है. और खुद से जब तुम लोग नेगेटिव के इधर लेफ्ट हैंड साइड शिफ्ट कर रहे हो, तब प्लस आता है. Okay, when you all are shifting willingly. But if I have given you all, for example, if I give you 2.5, okay, if I give you 2.5 into 10 raised to 1. So in this scenario, what will you all do? In this scenario, I have told you all what to do. So just follow the sign simply. Because it is raised to +1, go on right hand side. So ये हो जाएगा 25. I hope you all are understanding. When it is given, you all are supposed to follow the exact sign. पॉजिटिव है तो राइट में शिफ्ट करो, नेगेटिव है तो लेफ्ट में शिफ्ट करो. बट जब तुम लोग खुद से शिफ्ट करते हो, okay, let me just quickly erase all these parts. Just 1 second, okay, so that you all don't get confused. Okay, so when you all are supposed to shift on your own students, you all have to take the opposite this thing. So if you all are going in the left hand side, what will be the sign that will come? Plus sign. Okay, so इधर decimal left hand side shift करो तो क्या आएगा? Into 10 raised to 1. So -10 + 1 will give me -9, and this 0.1, okay, I'll write it over here. 0.15 into 10 raised to -9 is nothing but 0.15 nanometer. Students, ये जो आंसर आया ना अपने को, this is in meters. Okay, this is in meters. As I told, formula is in SI unit. So the answer is in meter. And this, if I remove this 10 raised to -9, it will become nano. Okay, everyone please let me know if you all understood this numerical and whatever shifting part that I explained to you all. If anyone has confusion, then you all have to tell me. Otherwise, I'll explain again if you all want. समझा क्या सबको?
Yes, miss.
Yes.
Yes, miss.
Okay, fine. Okay, good. So if you all understood, then very good. Okay, can anyone just read the third numerical for me? Yes. Okay, Ritesh read and Shraddha read. Now someone else read, please. Hare, read the numerical. Just look into your textbook and read. That's it. Okay, I'll ask someone to read. Wait. Yes, Angi, will you please read the numerical?
Yes, miss. The speed of the light is 10 raised to 8 meter per second.
Okay.
Calculate the frequency of red light of wavelength 6.5 into 10 raised to -7 meters.
-7 meters. Okay. Students, what is this red light? Don't worry. Red light is your red light of your this thing, rainbow. Okay. As I said in this numerical, what wave it is, it doesn't matter. First, look at the data that is given. Okay. So they have given us C, they have asked us frequency, and they have given us lambda. So again, same formula, yes or no? As I said, these numericals are very simple, students. We are using the same formula again and again. Okay, so now you all solve this on your own and tell me what the answer is going to be. Okay, see, the formula is C by mu, yes or no? If I need mu, so I'll take mu on the other side and this will become C by lambda. Substitute the values and you all have to tell me what the answer is. What is the answer that you all are getting? Done. Okay, Lenroy is done. Okay, you all have to solve. Okay, please don't give me answers directly from the textbook. I know there is an answer written over there, but that is just for checking purpose. Basic calculations you all are supposed to do. Okay, nothing much complicated. So like if C is 3 into 10 raised to 8, yes or no? And what is lambda? Lambda is 6.5 into 10 raised to minus 7. So what will happen when you all take minus 7 in the numerator, it will become plus 7, yes or no? So it is going to be 10 raised to 15. And then what will happen if you all will divide 3 into 3 by 6.5, and then you all can arrange the decimals according to the final answer. Okay. Okay, people are sending me answer. I hope everyone is solving. Okay, I'm waiting for everyone to solve. Okay, students, I want you all to solve. Let me just, okay. So let me just quickly write. I'll have 3 into 10 raised to 8 upon 6.5 into 10 raised to minus 7. So as I said, first let us solve this 10 raised to part. So this minus 7 will go into the numerator, and what it will be 10 raised to 15, right? 8 plus 7. Yes or no? And what is this 3 upon 6.5 going to give me? It is going to give me 0.415 something. See students, if you all feel that normal, see some people are really good at log calculations, they can do log very quickly, okay? So if you all feel that your normal division is going to consume more time as compared to a log calculation, go for log calculation, not a problem at all. How is this calculation going to be? First, see, I'll write anti-log. Okay, then it is going to be log of 3 minus log of 6.5. Do not touch the 10 raised to part. Let it, keep it as it is at this side. Use it at the end. Okay, this is how the log calculation will be. So first find log of 3, then find log of 6.5, subtract it. Okay, then find its anti-log. As simple as that. Okay, fine. So you all can do log calculation as well, students over here. It's not a problem. But I feel that these calculations are little simple. Like there's no need to go for log and all, because you all have to write a lot of stuff. Okay, yes, many of you all are sending me correct answers. Good students. Okay, now if I have to, you all can leave the answer here. There's no need to see in exam. They are not going to give you the final answer, right? Okay, if it is specifically mentioned, like the first two questions, express in megahertz, express in nanometers, then you all have to stick to that. You all have to do that. But if anything that sort of is not mentioned, you all can leave your answer here. But do not forget to put units. Finally, like you all have to write mu, then put a box around it. I don't know what you all are doing, but the answer should be highlighted along with unit. Now, if I have to arrange this according to textbook, so in textbook they have expressed in terms of 10 raised to 14, right? So अगर 15 को 14 बनाना है तो -1 आना चाहिए, और अगर -1 आना चाहिए तो डेसिमल को कहाँ शिफ्ट करेंगे? राइट हैंड साइड में. तो ये क्या हो जाएगा? 4 point. Okay, this thing I wrote incorrect. So sorry, you are 461. So this will become 4.615. Okay, yes or no? Everyone, please let me know if you all understood this third numerical.
Yes, miss.
Yes, miss.
Yes.
I hope you all are solving along with me. Okay, solve it now itself. Then later you all don't have to solve it again. Okay, very simple numericals. As I'm explaining, go on solving along with me. Okay, fine. All right, so now let's go to the next numerical. Okay, see students, so simple. Like we are hardly taking 5 minutes for one numerical, that's it. But see to it that in exam you all do the calculation properly. Do the calculation, do the decimal shifting properly, then write the sum properly, put the final answer in a box. All these things you all have to do on your own. Okay, fine. Okay, can anyone just read the fourth sum for me? Okay, I'll take a name. Wait, you all will take half an hour to decide. Yes, Melissa, can you read the fourth sum?
Yes, miss. Calculate the frequency of a microwave of frequency. Calculate the wavelength of a microwave of frequency 8.0 gigahertz.
Okay, of frequency 8.0 gigahertz. Yes, and microwave is given. Okay, again which wave, it really doesn't matter over here. Wavelength पूछा है, frequency दिया है, again the same formula students. Okay, fine, all right. C by F, simply put C, we know C is nothing but 3 into 10. Okay, students, one more thing that I wanted you all to note is that sometimes in question they don't give the value for C because it is expected that you all know the value. So it is your job to mention it in the data. Okay, like in this question, see, I'll write the word data. Mu is given to me. Okay, now C तो पता ही होगा, but उसको लिखना है पेपर में, उसको डेटा के नीचे लिखना है 3 into 10⁸ meter per second. You all are supposed to write it. Everyone knows that C ka value is 3 into 10⁸ meters per second, but it is your job to mention it because you all are using it right ahead in the calculation. You all are using it, so you all have to mention it. Okay, fine. So just do this one thing. Like these are certain things that you all should do on your own. Okay, fine. Okay, just 1 second. Okay, and what is mu? Okay, can anyone quickly tell me how much is giga? Giga
10
matlab
raised
kitna?
to 9.
Yes, correct, correct. Giga is 10, very good. Giga is 10⁹ Students, ये सब याद रखना है, ठीक है? Mega मतलब कितना, giga means कितना, and all you all have to remember. Okay. Yes, Landroy, correct. Okay, fine. Now, simply solve this and tell me what is the final answer that you all are getting. You all have to do 3 by 8. Okay, you all have to do 3 by 8, and then what is this part going to be? 10⁸ and then 10⁹ numerator में जाएगा तो क्या हो जाएगा? -9, right? So 8 minus 9 मतलब 10⁻⁻1. Just tell me what is 3 by 8 that you all are getting. Don't give me the final answer, student. The final answer is in centimeter, I know that, but again, see, formula is SI unit. Okay, the sum that we are doing is in SI. All the formulas are in SI unit. तो तुम लोग को जो lambda का answer आएगा ना, finally it is going to be in meters. You all can leave the answer here because you all have seen the final answer. इसीलिए तुम लोग ने सेंटीमीटर लिखा ना. मैंने मेंशन तो नहीं किया था क्वेश्चन में सेंटीमीटर में करो. समझ में आ रहा है? तो एग्जाम में मीटर में छोड़ोगे आंसर चलेगा. Until and unless it is specifically mentioned that write the wavelength in centimeter, then you all are supposed to do the conversion. I hope you all know the conversion. I've explained this last time. 1 meter is 10⁻² centimeter. तो जब मीटर से सेंटीमीटर जाते हो तो into 10⁻²करने का, सेंटीमीटर से मीटर आओगे तो डिवाइड बाय 10⁻² करने का. ओके, फाइन. सी स्टूडेंट्स, नाउ हियर 3 by 8 का आंसर क्या आता है? 3 by 8 is 0.37. Just 1 second. 0.375. ओके, 0.375. अब इधर क्या है? 10⁻² में -1 है. It is given. हम लोग खुद से शिफ्ट नहीं कर रहे. It is given. तो -1, then go to left hand side. Okay. So if I shift the decimal on left, so this will become 0.0375 meters. So this is my final answer. But as you all can see in your textbook, the answer is mentioned in what? Centimeter. So can anyone tell me अभी ये मीटर से अगर मुझे सेंटीमीटर में जाना है तो क्या करना पड़ेगा? What am I supposed to do?
Divide by 10⁻².
Right hand side में decimal shift.
हाँ, decimal shift on which side?
Right side.
Inside.
On the right hand side. Why you all did that? Why decimal shift on right hand side?
Into 10.
Into 10⁻².
Into 10⁻². Okay, fine. See this relation that is there, students. See, ये relation होता है 1 meter is 100 centimeter ना. 100 मतलब 10⁻² centimeter. So now I have to go from left to right. Okay, that is from meter to centimeter. So I will multiply 10⁻². But when I have to go from centimeter to meter, I divide 10⁻². Divide मतलब वो divide वो ऊपर जाएगा तो क्या हो जाएगा? 10⁻² हो जाएगा ना. तो basically हम लोग multiply कर रहे हैं 10⁻² से. Okay, this part is important. See. Now here I have to go from where? From meter to centimeter. So what will I do? I will multiply by 10⁻². Okay, fine. I hope you all are understanding. So here, let me just quickly erase this. Okay, fine. Just 1 second, students. All right. So here, the 0.0375 into 10 raised to 2, because I have to go from meter to centimeter. So, 2 place shift hoga na, 2 place shift hoga. So, 3.75 centimeter is my final answer for lambda. Okay, fine. Everyone, please let me know if you all understood this fourth sum.
Yes, miss.
Okay, what about others?
Yes, miss.
Yes, miss.
Okay, fine. Okay, very easy numerical, students. All right. Now, someone please quickly read the fifth sum for me. Achha, who will read? Okay, I only have to tell who will read. Yes, Srinidhi, please read the fifth sum.
Yes, miss. In a EM wave, the electric field oscillates sinusoidally at a frequency of 2 into 10 raised to 10 hertz. What is the wavelength of the wave?
Okay, fine. So there is a EM wave. They have given us the frequency for it. They have asked us what is the wavelength, and the EM wave varies sinusoidally. That is what EM wave is, right? I hope you all remember electric field, and then there is magnetic field, which is perpendicular, and all these things we have done already. Okay, so that is just a little bit description about EM wave that we have given in the question. Actually, we do not need that for our sum. Okay. Again, students, same formula, C by mu, okay? Put C, put mu, and tell me what is the answer that you all are getting for this sum. Done. Okay, Lendra is done. Again, I'm repeating, students. See, I know that you all are directly using C's value as 3 into 10 raised to 8. But in exam or when you all are writing test, it is your job to mention C in data. Like along with mu in this scenario, you all are supposed to write C as well with the unit meters per second. Don't simply write 3 into 10 raised to 8. In data, okay, there's no need to write units when you all are writing calculations. I don't know why you all must have seen reference books or your targets and all those things where they write units while doing calculation. There's no need to do that. Okay, just write units when you all are writing data and when you all are writing final answer. That's it. Okay. Some of you all are sending me the answer. What about others? I hope everyone is solving. Please tell me what the final answer is. Okay, if I put mu as 2 into 10 raised to 10, very simple. Yes, yes, many of you all are sending me the correct answers. Okay, good. मिस 2 मार्क्स के क्वेश्चन में भी लिखना जरूरी है हाँ ऑफ कोर्स जरूरी है दो इफ इट इज एन एमसीक्यू ऑब्वियसली एमसीक्यू में तो तुम लोग रफ वर्क में करोगे ना तो फर्क नहीं पड़ता है 2 marks ho 3 marks ho 4 marks ho I don't know numericals have to be in this pattern only okay see students these are very simple sums so you all can't take a chance of losing marks over here okay because in theory questions you all don't get full marks you all might get full marks you all or you know it depends on the examiner but numericals are something that you all can 100% get full marks provided you all have written everything properly I can find any mistake okay if unit nahi likha I can cut marks calculation nahi dikha I can cut marks yes or no C nahi likha I can cut marks okay so do not leave the scope to get your marks cut okay so if even if it's for 2 marks you all have to show the everything properly okay if it is a one line for example like if it is a one answer in one sentence or in that they expect only the final answer but from 2 marks onwards you all have to write everything and ye jo numericals abhi hum log kar rahe hain 2 marks ke liye aayega kitna chota chota sums hai theek hai so okay many of you all have sent me the correct answer what is 3 by 2 3 by 2 is 1.5 and 10 raised to 8 और ये 10 raised to 10 ऊपर जाएगा तो क्या हो जाएगा 10 raised to minus 2 meter. This is my final answer. Now what you all can do is, you all can leave the answer here students, not a problem. Or what you all can do is, you all can shift the decimal. -2 है ना, तो लेफ्ट हैंड साइड 2 पॉइंट शिफ्ट हो जाएगा, तो 0.015 मीटर इज माय फाइनल आंसर. Okay, everyone, please let me know if you understood the fifth numerical.
Yes, miss.
Yes, miss.
Okay. Okay. All right, fine. Okay, now let us do the sixth numerical. As I said, 7th, 8th, 9th we'll be doing later because it is based on the next concept, the concept that we have not covered yet. Can anyone just read the sixth numerical for me? Who will read? Who will read the sixth numerical? Wait, I'll tell you again. Yes, Vinayak. Vinayak, will you please read the sixth numerical? Yes, where's Vinayak? एक minute, हाँ. Okay, yes, where is Vinayak? Vinayak, please read the numerical for me. So sorry for the disturbance, students. मेरा नेट स्लो है. अरे तो ऑडियो ऑन करके रीड तो कर भाई. नेट स्लो है, क्या रिलेशन है? अच्छा ठीक है, I'll ask someone else. कुछ भी रीजन देते हो यार तुम लोग. Who will read? Vaishali, will you please read the next numerical?
Yes, miss.
Yes.
6. The amplitude of the magnetic field part of a harmonic EM wave in vacuum is B0 is equals to 5 into 10 raised to minus P. What is the amplitude of the electric field part of the wave?
Okay. Can you just please repeat the B naught value, dear? What is the B naught value?
5 into 10 raised to minus 70.
Minus 17.
7 minus 7.
Okay. Minus 7. All right, fine. Okay, so see students, again, this question is a little different. It's not the lambda is equal to C by F formula, but we have already seen this type of numerical in the solved examples. I hope you all remember that. Here you all are supposed to use one relation. Now, EM wave, our EM wave is made up of what? EM wave is made up of electric and magnetic field, yes or no? Electric and magnetic field are perpendicular to each other. Changing electric field produces magnetic field. Changing magnetic field produces electric field. Yes or no? And here, if you all remember, one relation is satisfied. And what is the relation? That is amplitude of electric field to amplitude of magnetic field is nothing but equal to C. C is the speed of EM wave in vacuum. Okay, I hope you all remember this relation. We did it in the characteristics. Yes or no? 1 second. Yes, Lenroy, correct. So now here, yes, Nandini, correct. So here what we'll do is, I have to find E naught, right? So I'll cross B naught on the other side. So basically in the solution part, what I'm going to have E naught is equal to C into B naught. Yes or no? Again, I know what C is, I know what B is. Can anyone tell me the final answer they are getting for E naught? Yes, Lenroy, correct. What about others? Shraddha, we are just supposed to multiply both of them. Just multiply the two. See now, see student, this is the relation, okay? E naught upon B naught is equal to C. E naught ढूंढना है तो B naught क्रॉस करो, C का जो भी वैल्यू है, ओके, इनटू B naught का जो भी वैल्यू है ना? तो ये क्या हो जाएगा, सिर्फ मल्टीप्लाई करना है. Yes, correct, Nandini. So students, here see what will happen. What is 5 3s are 15, and then 10 raised to 8 and 10 raised to minus 7 will give me 10 raised to 1. So this is nothing but 150. Now what is the unit? I hope you all remember. For magnetic field, the unit is Weber per meter square, or you all can write Tesla. For electric field, you all can write volt per meter, or you all can write newtons per coulomb. Anyone will do. Okay, so here in your textbook, they have written volt per meter. This is my final answer. Okay, fine. Everyone, please let me know if you all understood the sixth numerical.
Yes, miss.
Yes, miss.
Yes, miss.
Okay, fine. Okay, just 1 minute. So students, as I said, the 7th, 8th, 9 numericals we'll be doing later. Now, I hope everyone has solved. I'll be asking some of you all. Please unmute and answer. Yes, Janice, you have solved all 6 numericals?
Yes, miss.
Okay, good. Yes, Roshni, have you solved?
Yes, miss.
Okay, good, good. Zamir? Zamir, have you solved all the 6 numericals that we discussed just now? Please unmute and answer. Yes, there is
Yes,
Zamir.
yes, miss.
Okay, okay, good, good. Uh, um, yes, Sumer. Sumer, have you solved the numericals? Sumer Singh.
Yes, miss.
Okay, good. So I'm assuming that everyone has solved. Okay, very simple numericals. Now, what we'll do is, let us quickly go to the textbook now. Okay. Okay, let me just go. So as I said, students, see your what is your electromagnetic? Okay, I came very above it. Where is that page? 1 second, okay, students. Let me just go to that page. Okay, fine. So now, as I said, your EM waves that are there. All right, we have discussed this at the beginning. There are a lot many applications for EM waves. So there is a starting frequency, there is an ending frequency. In fact, last time I showed you all this table. Okay, where that blue table. Yeah, so this blue table that is there, students. This entire start to end frequency, that entire range, it is known as electromagnetic spectrum. Okay, and this entire electromagnetic spectrum is divided into various bands, various different categories. Okay, every category has its own starting point and end point, and every category has its own name. Okay, so like this is, you all can see, we have this order. Okay, just 1 second. This is very sensitive. All right, fine. So you all can see here, we have gamma rays, then X rays. You all have to follow this particular order. Okay. Then we have gamma rays, X rays, etc., etc. So we will be studying each of them quite in detail. Now, if you all remember, see, we'll be starting with radio wave, students. Okay. Just 1 second. There's the marker thingy. Okay. Okay, fine. So wait, I'll take some other color. Okay, so we will be starting with radio wave, students. Okay, see, not much is explained, like just 1-2 points about what type of waves these are, and then 2-3 applications they have given, which is the important part. Okay, the applications are important, like radio waves is exactly used for what, and along with that, what is the range? Can't hear anything. Okay, others, even you all can't hear. Others, can you all hear me?
Yes, miss.
Yes, yes, miss.
Then I think so some network issue is happening. Yes, Lenroy, now can you hear me? And is there anyone else who is facing a problem? Then please let me know. If I can't hear, wait, I'll just be. I am not sure why this is happening. Maybe because of network issue only. Okay, Hetvi also cannot hear me. Okay. Okay. See students, while I'm explaining, I see to it that I just increase my volume so that it is clear enough. If you all can hear the explanations part properly, then I think so that is more than enough. Maybe next time what I'll do is next time I'll put a earphones and then I'll take, okay? Because that time microphone is little near, so then the voice is more clear, all right? Lenroy, now can you hear me? Lenroy and Hetvi, now are you all facing any problem? And others also, if any problem is there, then please let me know. I'm not even sure if Lenroy can hear me. Wait. Okay, Vaishnavi is telling in between. Okay, fine. Maybe see, maybe sometimes I lower my volume. I think so that is the problem. Wait, let me just ask Lenroy. Oh no, I sent it by mistakenly to it. Okay, is there anyone else? Any other student is facing this problem? Please tell me in the chat box. Is this guy here in the lecture? Okay, I think so he left the meeting. Okay, fine. So I'll continue, students. Okay, so as I was saying, we'll start with radio waves. Okay, now this table that is there. Okay, this table that is there, students. So in this table, if I just go a little bit above, okay, just 1 second. You all can see the first column that is there after the name. There is wavelength in meter, and frequency range in hertz. Now I told you all this last time as well. There is no need to remember both the columns. Okay, you all are just supposed to remember one column. The other one you all can easily find using the formula lambda is equal to C by F, or lambda is equal to C by mu. Okay, fine. All right. So let me just. Okay, fine. So yeah, so see students, this is radio waves. This is the wavelength range for radio waves, and this is the frequency range for radio waves. Okay. Okay, fine. You can hear now. All right. All right, students. So as I said, I would suggest always remember the frequency range. Now this range is in hertz. You all can see for radio waves, the range starts from 5 into 10 raised to 11 hertz till 8 into 10 raised to 9 hertz. Okay, fine. See students, you all might sometimes see different values. Like for example, 8 into 10 raised to 10 can be written as 80 into 10 raised to 9, and this can be written as 80 gigahertz. Yes or no? Something like this you all can also see. So that is the reason you all should know how the conversion happens. Remember what is given over here. For radio waves, frequency range in hertz is 5 into 10 raised to 11 to 8 into 10 raised to 10. But what if in options, like if I give you an MCQ and there are 4 different options, you all won't see, it's not necessary that you all will see the exact same value. Okay, as I said, this 8 into 10 raised to 10 can also be written as 80 gigahertz. Then you all should not think of it as some wrong option. No. Okay, fine. That is the reason what giga stands for, mega stands for. You all should know all these things. And as I was saying, just remember frequency in hertz range, because if you all know this, you all can easily find the wavelength in meters range. How? I'll tell you all. See. Now here, this is the frequency, right? So for wavelength, what is the formula? C by mu, right? So what you all have to do, you all will simply do 3 into 10 raised to 8, okay? 3 into 10 raised to 8 divided by 5 into 10 raised to 11, and that is going to give me 6 into 10 raised to minus 4. Okay, I hope you all are understanding. Similarly over here, 3 into 10 raised to 8 upon 8 into 10 raised to 10 will give me this value. Okay, fine. I hope you all are understanding. Now this last column that is there, don't worry about it, because every wave we are going to study in detail, like what is radio wave, microwave and all. So it is basically the last column is kind of summarizing everything that we'll read. Okay, fine. So we can get back to this table after we finish the reading part of all the waves. Okay. So don't worry students, today I'm not going to cover each and every wave, but I'm planning to cover few of them. So let us start with first radio waves. Okay, fine. All right. So let us read what is written. Radio waves are produced by accelerated motion of charges in a conducting wire. What is a conducting wire? A conducting wire is something that is carrying current in it. And how is the flow of current happening? Through flow of charges, right? To be more specific, through flow of electrons. Yes or no? So radio waves, how they are produced? So in a circuit, in a current carrying circuit, radio waves can be produced because of the moving charges that are there. Okay. Okay, आवाज break हो रहा है. Okay. I have no idea, students, why that is happening, because some of you all can hear me clearly and some of you all are telling that it's not clear. Just bear with me for this lecture. Next time onwards, I'll put earphones, then it will be more clear. Okay, fine. So, students, this part is very important. Just mark this first point. Okay, just mark this first point. That is, radio waves are produced by accelerated motion of charges in conducting wires. Okay, just mark this point. Okay, fine. Now let us read what is written. The frequency of waves, okay, wave frequency, the radio wave frequency. Radio waves are produced because of the moving charges in wires, okay, or maybe in circuits. So the frequency of the waves produced by the circuit will depend upon the magnitude of inductance and capacitance. Okay, you all have to tell me, have you all heard these words before? Inductance, capacitance, पहले सुना है? Yes, students? No, miss. Okay, what about others? Please respond. Have you all heard inductance, capacitance before?
No, miss.
Okay. Now, what I want you all to do is, I want you all to note down some statements. Okay, before I start dictating the statements, let us read what is written over here. You all can see the frequency of the radio waves produced by the circuit depends upon the magnitude of the inductance and the capacitance. Now, students, see, this is a concept that you all are going to study in more detail in your 12th standard. They have written it over there. This will be discussed in 12th standard. Like how actually frequency depends on inductance and capacitance. Again, it is a little bit in-depth concept. We don't have to go there, but you all should know what inductance and capacitance means at least. So I'll dictate those terms, like I'll dictate the, I won't say definition. Capacitor सुना है, हाँ बराबर. So capacitance is related to capacitor, inductance is related to inductor, resistance is related to resistor, है ना? तो वैसा ही relation है ये भी. So I'll just tell you all what inductance, capacitance is. How to determine frequency using that, we won't get into that detail. Okay, fine. So what you all do is, very first thing, students, note down what a capacitor is, what an inductor is. That is very much important. Okay, so you all can write it down in your textbook. Maybe somewhere over here, or maybe you all can write it down in your notebook. यहाँ पे लिख सकते हो, ठीक है? यहाँ पे लिखो चाहिए तो पहले तो लिखना है कि कैपेसिटर क्या है और इंडक्टर क्या है. So first I'll dictate for capacitor. Okay. So write down, a capacitor stores energy. A capacitor stores energy in an okay. A capacitor stores energy in an electric field. A capacitor stores energy in an electric field. A capacitor stores energy in an electric field. Then next write down what an inductor is. Okay. An inductor stores energy in a magnetic field. An inductor stores energy in a magnetic field. Okay, so I'll repeat. A capacitor stores energy in an electric field, and then an inductor stores energy in a magnetic field. Everyone, please let me know if you all have noted down these two statements.
Yes,
Yes.
Miss.
Okay, students, see, I have not told you all what inductance and capacitance is. Okay, and I have told you all what a capacitor and inductor is. Those are devices. Okay, अगर मैं अगर symbol बताऊं, देखो तुम लोग का resistor कैसे होता है ऐसे. Okay, just 1 second. Okay, so this is the symbol for your resistor, right? A resistor provides resistance, yes or no, to the flow of current. Inductor का symbol ऐसा होता है, capacitor ऐसा होता है, ठीक है? Two parallel plates, okay? Don't get confused, this is not your voltage वाला नहीं है, ये capacitor में दोनों plates parallel होता है, okay? Fine. So I told you all what a capacitor is and what an inductor is. Now I'll tell you all what capacitance and inductance is. So I know students, I mean, जगह नहीं होगा, थोड़ा adjust करके लिख लो. Next, you all have to write what capacitance is. Okay. So write capacitance in bracket. Write down capital C. देखो तुम लोग resistance को कैसे capital R से denote करते हो, वैसा ही है ये. Capacitance को capital C and then write down what I'm dictating. Capacitance is the capacity. Capacitance is the capacity to store energy in a capacitor. A little bit like a tongue twister. This is capacitance is the capacity to store energy in a capacitor. Capacitance is the capacity to store energy in a capacitor. अभी लिखा ना capacitor क्या, it is a device that stores energy and उसका capacity of storing energy that is determined by something called capacitance. जैसे एक resistor कितना resist करता है वो resistance से पता चलता है ना, तो वैसे एक capacitor कितना energy store कर सकता है वो capacitance से पता चलता है. I hope you all are understanding. Next we have inductance. So write inductance and in bracket, just 1 second. Just 1 second, okay, students. In bracket, write down capital L, okay? Write capacitance and in bracket, write down capital L. Capital L, okay? Oh, so sorry, write inductance. So sorry, write inductance and in bracket, write down capital L. And then in front of that, write down what I'm dictating. Inductance is the inductor's capacity. Inductance is the inductor's capacity to resist. Inductance is the inductor's capacity to resist variation of electric current. Inductance is the inductor's capacity to resist variation of electric current. Okay. Another thing that you all can note down is that students, देखो तुम्हारा resistance कैसे ohms में measure होता है ना, तो वैसे ही जो तुम्हारा capacitance है वो farad is the unit that is used to measure capacitance, and for inductance the unit used is Henry. Okay, ये units है, ठीक है? Capital F stands for farad and this H stands for Henry. Okay. Everyone, please let me know if you all have noted down what capacitance, inductance, and whatever I dictated till now. And if anyone wants me to repeat anything, then you all have to let me know. Note down किया क्या सबने?
Yes, Miss.
Yes, Miss. Yes, Miss.
Okay, what about others? People who are not responding, please let me know if you all have noted down or not.
Yes, Miss.
Yes.
ठीक है? Okay, good. So students, see, radio waves are produced because of the moving charges in a circuit or maybe in an electric current and all. Okay. Achha, okay, wait. I had to tell you a little bit about inductance. See, capacitance का definition काफी straightforward है. Inductance का देखो क्या है? It's the inductor's capacity to resist the variation of electric current. Students will remember. See, this is how your inductor looks like. It is like a coil with many turns. Okay, like this is it's like that actually. अगर थोड़ा अच्छे से ड्रॉ करूं, ये ऐसा इंडक्टर होता है, उसका सिंबल हम लोग ऐसे बनाते हैं, ठीक है. सो इन दिस कॉइल व्हाट हैपेंस, देयर इज करंट फ्लोइंग, राइट. Changing current produces a magnetic field. I have already explained this to you all. Okay, changing current or flowing current produces a magnetic field. Changing magnetic field induces a current. Okay, ये दो concepts है जो थोड़ा बहुत side by side चलता है. Farad, F-A-R-A-D. Okay, that capital F is unit of capacitance. Farad. Okay. एंड वो जो H था, कैपिटल H, कैपिटल लिखना, स्मॉल नहीं लिखना है. जैसे ओम्स कैसा ये सिंबल है ना ओम्स का, वैसे फैरेड इज कैपिटल F एंड हेनरी इज कैपिटल H. हेनरी HENRY. ओके, फाइन. Yeah, so as I was saying, see, inductor is like a coil. Okay, it's like the device is a coil with n number of turns. So the current is flowing. Changing current produces a magnetic field in it. Okay, fine, all right. So inductance is the inductor's capacity to resist the variation of that electric current. So जो changing current है उसको inductor resist करने की कोशिश करता है. Resistor क्या करता है? Flowing current को resist करने की कोशिश करता है. Inductor वो जो change in current हो रहा है उसको resist करने की कोशिश करता है. That is known as inductance. Okay, I think so this much is enough for you all to understand what this particular statement is. And at the end just remember that जो radio waves produce हो रहा है उसका frequency depends upon the magnitude of inductance and capacitance. Thus, by choosing suitable values of inductance and capacitance, radio waves of desired frequencies can be produced. So, from a circuit, okay, there is a circuit and you all want radio waves of a certain frequency. एक certain frequency का हम लोग को अगर radio wave चाहिए तो उस हिसाब से तुम लोग को इंडक्टर और कैपेसिटर लगाना पड़ता है वो सर्किट के अंदर. समझ में आ रहा है? ठीक है, फाइन. So this was a little bit introduction about radio waves. Now, what are the properties of radio waves? Just 1 second. Okay, we'll just do radio waves. Okay, then we'll stop. Okay, what are the properties for radio waves? All right, so let's see the first property. They have very long wavelengths ranging from few centimeter to few hundred of kilometers. Okay, fine. इसका wavelength का range काफी ज़्यादा है as compared to other this thing. The frequency range of AM. अच्छा students, what is this AM, FM? FM radio पता है ना? तो AM, FM radio जो है तुम्हारा, it operates in this radio wave band. Okay, all the frequencies that your radio channel ka frequencies and everything, and you all can see the frequency range of AM band is 530 kilohertz, small k stands for kilo, to 1710 kilohertz. Students, this second point is very important because you all are supposed to remember these values. They might ask these values in MCQ, and if they give you a short note, like write a short note on radio waves, then you all have to mention this. Okay. All right. So see, AM band ka frequency range ये है. Frequency of the waves used for TV transmission. Your TV transmission के लिए जो waves लगता है वो भी radio waves ही है. Okay, fine. उसका range कितना है? 54 megahertz to 890 megahertz. While those for FM radio. See देखो, AM और FM ये दोनों radio है for voice. Okay, fine. What is the range for FM radio? It is 88 megahertz to 108 megahertz. Or I can simply give you a MCQ. Which of the following is the frequency range for FM radio? Then you all have to select this particular option. So the second point is like really important. Okay, fine. Now students, see, does anyone know what is this AM and FM radio? तो सुना रहेगा बहुत बार, लेकिन ये जो AM FM है उसका full form क्या है? किसी को पता है? What is the FM meaning क्या है? या AM meaning? What is A and M for? Or what is F and M for? Does anyone know? Yes, no. कुछ तो बोलो. See students, your AM stands for, okay. Yes, miss. Okay, Lendroy, please answer then if you know what it is. Just 1 second. Yes, correct. Very good, Lendroy. Okay, fine. See students, your AM stands for amplitude modulation. Okay, AM stands for amplitude modulation. You all can note this down, okay? And your FM stands for frequency modulation. Okay, fine. ये जो तुम्हारा AM रेडियो, FM रेडियो है, तो ये AM, FM क्या है उसमें? Yes, correct. Frequency modulation, AM stands for amplitude modulation. Correct, absolutely correct. Do you all know what this means? ये modulation का मतलब क्या है? Do you all know that? Yes, students, you all know the full form. Okay, some of you all know the full form. Very good. But what is this modulation? See, the thing is, okay, if you all don't know, don't worry. I'll explain that. Not today. It will consume a little bit time. So I'll explain that next time. But you all have to remind me, okay? Let us quickly see what the uses are. Radio waves are used for wireless communication. Your wireless communication that you do in your day-to-day life uses radio waves. They are used for radio broadcasting. Abhi just dekha na, AM radio, FM radio. And then they are used for transmission of my TV signals. Cellular phones use radio waves to transmit voice communication in the ultra high frequency band. Actually, see students, your radio waves that are there, जैसे तुम्हारा इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम कैसा अलग अलग पार्ट्स में डिवाइडेड है, अलग अलग फ्रीक्वेंसी रेंज में, वैसे ही तुम्हारा रेडियो वेव्स भी डिवाइडेड है इनटू मेनी फ्रीक्वेंसीज, लो फ्रीक्वेंसी, हाई फ्रीक्वेंसी, वेरी हाई फ्रीक्वेंसी, अल्ट्रा हाई फ्रीक्वेंसी एंड ऑल. एंड इन दोज रेंजेस this is like a specific range for specific application. Okay, you all understanding? These are applications. AM radio, FM radio, TV signal. तो applications का ये specific range है. लेकिन जो radio waves है तुम्हारा, it is bifurcated into many sections. Again, I have a diagram. I have this thing for this. I'll show that to you all next time. So don't worry about it. Okay, fine.